In this video, we are going to discuss some board questions, previously asked board questions for predicting formula of a complex through precipitation method. Look at this question. A complex formula is given. It's PtCl4 6NH3. Okay. So to the solution of this complex, you're adding silver nitrate so that 4 moles of AgCl is precipitated. So from this precipitation details, you have to find out the structural formula of the complex. Okay. So it's given PtCl4 6NH3, right? So out of this, so you should know how many ligand Cl is present and how many counter ion is present. So that you can understand from the precipitation details. Okay. So remember, you're adding silver nitrate, right? So when you add silver nitrate in the solution, it's split up into Ag plus and NO3 minus. Okay. And to precipitate AgCl, okay, we need Cl minus ions, right? You need free Cl minus ions in the solution. Then only you can AgCl precipitation is possible. Okay. So a Cl minus will be free only if it present as counter ion. Okay, only if it is present as counter ion. If it present as a ligand, okay, a metal ligand bond, okay, that's a coordinate bond. It will not split in solution, so you won't get Cl minus. So Cl minus will be getting if it is connected with metal, okay, not through coordinate bond. Okay, so it has to form a counter ion. So how many AgCl is precipitated? 4 mole of AgCl is precipitated. So remember, if you want to get 4 mole of AgCl, you need 4 Cl minus ion, right? 4 free Cl minus ions. Okay, so you'll get 4 free Cl minus ions, okay, in the solution only if it present as counter ion. Okay, so it's very easy now. Remember, it's like there will be 4 Cl4 outside the coordination sphere. So what all, like there are 4 Cl4 is given in the formula, all the Cl is outside the coordination sphere. Okay, now how many ligand is present? 6 ammonia. So metal, 6 ammonia. Okay, so it's an octahedral complex with 6 ligands, and all the 4 chloride, okay, is present as counter ion, not as a ligand. That's why you're getting 4 mole of AgCl. So what is the answer? The answer is it's PtNH3 6 times Cl4. Okay, and give the IUPAC name. Already we discussed how to name the complex. Okay, so this is going to be hexaamine platinum. It's a positive complex, so name of the metal as such, platinum. What is the charge? -4 outside, so complex charge will be +4 for balancing. Okay, so no charge from ammonia, so it's 4, platinum 4 chloride. Okay, so you have to identify the number of counter ions from the precipitation details. That's it. Okay, it's very simple, right? Now look at the second example. Like it's, you have to be much more careful dealing this, because okay, there are the total like 6H2O, 3Cl is given, right? Okay, look at the details. Like so 2 mole of AgCl is precipitated. So you have this complex CrCl3 6H2O, and you're adding AgNO3 into it, and you're getting 2 mole of AgCl. So to precipitate 2 mole of AgCl, what we need? We need 2 mole of Cl minus, right? 2 Cl minus. So 2 Cl minus should be free in the solution. That is possible only if they present as counter ion. Okay. So if from this formula, if you take 2 Cl outside, 2 Cl outside, then what all things remains? You have 1 Cl and 6H2O, right? So total how many ligands? 7 ligands. 7 ligands. So 7 ligand, is it possible? Okay, so remember we are studying only complexes like with maximum 6 ligands. 6 ligands. So 7 ligands are not possible. Only 6 ligand is possible. Okay, so what to do? So 6H2O, 1 Cl. Anyway, you cannot take Cl outside. If you take Cl outside, it will be Cl3. So it's supposed to get 3 AgCl, right? That's not possible. So Cl is a ligand, one Cl is a ligand. So now what is the only possibility? Okay, you have 6 H2O, right? So you can keep 5 H2O as ligand, and the sixth or the next H2O, you can keep it as water of hydration. So all the water is not ligand, 1 mole H2O will be present as water of hydration. So what's the formula then? CrH2O 5 times 1 Cl is inside the coordination sphere. How you understood that 1 Cl is inside? Because only 2 AgCl is precipitating. So only 2 Cl is outside. So Cl2. So one more water left, that will be present as water of hydration. Okay, dot H2O. It's outside the coordination sphere. It's not a ligand now. It's not a ligand, it's just water of hydration. Okay, so how to name this? It's a negative complex. So aqua and chlorido, right? So alphabetic preference. So penta, aqua, chlorido, chromium 3, chloride. It's one H2O, right? So we say, right, monohydrate. So already we discussed how to name hydrated salt, like in the previous video. So it's monohydrate, half H2O, hemihydrate, 2H2O, dihydrate, like that. Okay, I hope it's clear. So only thing, this is to be careful because you cannot have more than 6 ligands, okay, inside the coordination sphere. Maths means 6 is allowed. So if anything extra is coming, it should be outside, but should not, you cannot take Cl here because it's given only 2 AgCl is precipitating. Okay, if it's clear, we'll see one more example, last example. Okay, it's all previous years questions. I think this is a 2016 question, like Cu, like COSO4 Cl5HNO3. Okay, so this is the conventional formula. So it can exist in two isomeric forms, A and B. So this, with this formula, you can have two compounds, okay, A and B. So to the isomer A, if you add silver nitrate, you're getting a white precipitate, but you're not getting anything with barium chloride. So with A, if you add AgNO3, you're getting a white precipitate. With barium chloride, you're not getting anything. No precipitate. Okay, so look at that formula. It is COSO4 Cl5NH3, right? So remember, like if you add like Ag another this complex, okay, which is we are expecting to precipitate. We know AgCl is insoluble in water, right? So AgCl is a precipitate. Okay, with barium chloride, who's supposed to precipitate? Barium chloride is like soluble in water. Anyway, ammonia is not going to like interact with the barium. So only possibility is sulfate, right? So barium sulfate is a precipitate. Okay, so with the isomer A, okay, you are getting AgCl as a precipitate, and we are not getting like barium sulfate as a precipitate. Okay, so which means the isomer A, Cl minus is a counter ion. Okay, so what will be the formula then? The Cl minus is outside. That's why you're getting AgCl precipitate. So what left then? You have cobalt, 5 ammonia, total 6 ligand to be there. So 5 ammonia and SO4. Okay, so pentamine, sulfato, cobalt 3, chloride. Okay, that's a A. Understood. Now with B, for B, you are not getting like isomer B gives a white precipitate with barium chloride. So isomer B gives white precipitate with barium chloride, which means for B, sulfate is a counter ion, and you are not getting precipitate with AgNO3, which means there is no Cl minus outside. So what will the answer? Okay, the counter ion is sulfate. So it is CONH3 5 times. Cl is inside. So because Cl is inside means cobalt Cl bond is coordinate bond, it will not split. The cobalt sulfate, the counter ion is like maybe ionic, so it splits. Okay, so you get barium sulfate. as a precipitate. Okay, so it's pentamine, chlorido, cobalt, cobalt 3 sulfate. Okay, so here you asked to draw the structure, like write the structure of the complex. So these are the A and B. Okay, so this type of questions normally they ask for 1 mark. For entrance also this type of questions are very important. Okay, hope it's clear. Okay, thank you.